Okay, I decided to throw in one more example using this. So first question, max number of real zeros. So I already completed this one for you, but you can follow along. Max number of real zeros is 4. The highest exponent is 4. Possible rational roots. I did P over Q. So my P is plus or minus 2. Q is plus or minus 3. The leading coefficient, which is 3. And I divided. 1 divided by 1 gives me 1, so plus or minus 1. Plus or minus 2 divided by 1 gives me plus or minus 2. Plus or minus 1 divided by plus or minus 3 gives me plus or minus 1/3. And then plus or minus 2 over 1 again gives me plus or minus 2. I don't need it again. Plus or minus 2 over plus or minus 3 gives me plus or minus 2/3. Keep on going. Synthetic division. So I went through already and I found out which one would work. I did plug in 1 and -1, and 1 worked out just fine. I use synthetic division. You can take a look at it and notice I got a remainder of 0. Keep going here. Move this out the way. Now at this point I noticed I had 4 terms and it dropped the exponent down. It's to the 4th power. It dropped it down 1 and then I wrote it out. So I have 3x to the 3rd plus x squared minus 6x minus 2. Then what I noticed, I said, oh wait, I know another way to be able to factor. In this case, I said, let me factor by grouping, which we learned in previous chapters. So I grouped the first 2 terms together. That's what these blue parentheses are. I grouped the first 2 together. I chopped the middle, made it a plus negative, grouped those 2 together, and then I factored out. What comes out of both of these terms? X squared, and I'm left with 3x plus 1. What can I take out of both of these terms? I could take a negative 2 out. The leading term is negative, so I take out a negative, and I'm left with 3x plus 1. That's great. 3x plus 1 and 3x plus 1 are in both parts or both terms. So I factor out the 3x plus 1, and I'm left with x squared minus 2. Great. So now I have this all factored out, and now I can find all my zeros. All right, I already found one of the zeros up above. I found out that 1 was one of my zeros. All right, so my x-intercept will be 1, 0 for that one. Then I went ahead and set 3x plus 1 equal to 0, and I got negative 1/3, so another 0 will be negative 1/3, 0. And then I went ahead and set x squared minus 2 equal to 0 right here. Add 2 to both sides, and took the square root plus or minus, and I get plus or minus root 2, 0. So that's actually 2 different zeros, plus or minus, plus root 2, 0, and negative root 2, 0. I found the y-intercept. I plugged 0 in for x, and I got 0, 2. So if I plug in 0 for x, I would get 0, 0, 0, plus 0, plus 2, which is 2. So my y-intercept as an ordered pair is 0, 2. Standard function that this imitates is x to the 4th. That was the degree, the highest degree. And to the 4th power, it looks like this. It's an even integer. It's even high degree, and it was positive. So both rising for my leading term, for my end behavior to be. On the left side approaches positive infinity as x approaches negative infinity, and the right side approaches positive infinity, or the y approaches infinity as x approaches positive infinity. I should write that in real quick, just so you have that, as x approaches negative infinity and as x approaches positive infinity, which represents the left side and the right side of the graph. Were there any even multiplicity? No, I did not have any repeats. Even this is not a repeat. One's positive, one's negative. I didn't have any repeats, so there's no multiplicity. Remember, if there's multiplicity, it will have a bounce back. Possible extremes, that's n minus 1, so 4 minus 1, which is 3. And then extra values, I used negative 1. It gave me a value of negative 4 for the remainder. Check the synthetic division. So I have an extra order pair of negative 1, negative 4. Now you go ahead and throw this in your calculator just like we did before. And your graph should look something like this, plotting all of your x-intercepts at 1, 0, negative 1/3, 0, plus or minus root 2, 0. You got a few maximums and minimums. Again, like you can find all those values on your calculator and just see if you can sketch a graph like this without a calculator. Now you get a calculator on your test, but using all those things, you should be able to sketch with your y-intercept, end behavior, everything.